Okay, so I've been working on getting an AI car to be able to drive around the track. And in the previous video, I just set up these little yellow dots I'm calling checkpoints, and each checkpoint has a wall. I set up these yellow dots I plotted them around the track, and I made a little button here in my checkpoint script to angle the walls so that they all point to the next checkpoint. The thing I was going to do with the walls is have when a car drives forward and it passes through a checkpoint wall, the AI car would know to now point to the next checkpoint. So with these walls here, let me just press play and drive my car, which is this orange car, and just see how things are working. So I have my orange car and driving, and I bang into something. I'm banging into the checkpoint walls. So I noticed that that's my first problem is my checkpoint walls are colliding with my car. So my car is Duster and it's using a rigid body. So the collisions it's using are on collision enter, the rigid body collision. It's not using a trigger type of detection. So if I take my checkpoint walls and probably turn them to be triggers instead of not triggers, then the car could drive through them, but the on trigger event would hit. So let's see, the walls are all one of these prefabs here, the wall prefabs. So in my prefabs folder, here's my wall. So let me just change my prefab and click the is trigger so that now there are triggers instead. So the prefab is changed and all these were made off of the prefabs. So that means now if I click on wall 1, it didn't change that. All right, so good thing I checked. Let me just select all my walls on my track here and change to be using the trigger. Okay, so now with the walls having a trigger, let's see if I could drive through the walls. Okay, good. Now I could drive through the walls. They're still there. It's just that I could drive through them. All right, so just to keep things a little different, my car is the Duster and it's orange, you know. I just went ahead and without you guys seeing in a video, I made another car called Blue Magic. And here's Blue Magic. And that's just so we could tell the difference between the two cars. And Blue Magic is going to have a script that's going to tell it how to follow around these little checkpoints around the track. So I have pre-written that script and I will show you the script. It's complex. I'll just tell you right now. But there's some things I did in it. Up here at the top, I have two require component statements. I require a component rigid body and I require a component mesh collider. I put these here because when I make a model and I bring it into the game, as you can see, this model, it doesn't have a rigid body and it doesn't have a mesh collider. But I know that I'm going to need those two components. So I just had the script make sure to add them. So with these require component statements here, right before the class, when I drag the script onto my car, I just drag and drop it. It adds the script and it adds the collider and the rigid body for me automatically. Okay. So great. Now I have the script. Let's see some of the things that the script wanted. There's a move speed that defaults to 1.1, a turn speed 90. Drag is the grip on the track is a 1. Oh, it wants a game object. It wants to know what the track is. So I'm going to go over here. Here's my track. And I'm going to drag and drop it onto the track. There. Now there's a yellow button that we custom made for the script. It's called calc first checkpoint. And that's just so we can see based on where the car is, what's the point that it's going to be aiming to drive toward, based on its current location. So if I press this button, it shows that the first checkpoint it's going to try to drive to is that one. But that always depends on where the car is in the lineup. So let's see if I put the car here. That is a really bad checkpoint because it's not going to be able to make it to. And that's the next checkpoint. Okay, so, I think it's because of the angle of the car is facing. So let me say if this car was in the starting grid over here, and I guess it would be pointing this way, getting ready to start the race. Now let me see what the first checkpoint is. Nope, it's still that. Okay, so anyway, this is what the button does. It figures out a first checkpoint for the car to aim to drive toward. Let's look in the script. Okay, this is the AI control script. So it's going to have a couple of jobs. It's going to have to move the car, it's going to have to turn the car, and it's going to have to change the checkpoints as the car drives along the track. That's three things it's going to have to do. So let's open up the script and see what we have again. Let's just collapse the outlining because the script is a little bit bigger than normal scripts that I've had. So here we know what the require components do. They added in the rigid body and the mesh collider by default when I drag the script on there. Do we have any special using statements to add in more functions to our script? We did. Up here we use system.link for an order by somewhere. And over here we added in a system.text.regular expressions for a regex that we use somewhere. We'll see them when we go down. So we have some helpers here so that we didn't just get overloaded with variables here, but our public variables start off here as the first four was the move speed, turn speed, drag, and track. And those are the four things that we see that the script wanted: move speed, turn speed, drag, and track. Then we have private variables, an internal pointer to our rigid body. We have a private variable to the renderer component. So if we look at our car, the renderer component is right here. It's the mesh renderer. And that's what that's going to point to. And then we have a structure that holds some values for our car's AI, and we have a pointer to what the walls start with. What does that mean? I guess that's to see what the wall starts with the word wall, and then there's a number after it. Okay. Oh, so when the script starts up, first thing it does, it gets a pointer to the rigid body, and it sets the drag. Okay. So the rigid body here, the drag is 0, but when we press the start, the drag will be a 1. Remember, the drag is going to be how much the car kind of is going to like stick to the track. We're using rigid bodies, and if the drag is 0, it's just going to slide around like ice. If we give it a higher number, it's kind of going to have more friction. And then we set the mesh collider to convex. All right, so let's see what's going on with that mesh collider. There's Blue Magic. Let's zoom in. Okay, and here's the mesh collider. That means the whole object has a collider physically fit right to it. And if I say convex, it kind of does a collider that's, instead of being exactly where the model is, it's kind of like gift wrapped, like if we have gift wrapping paper on it. Okay, so when the game starts up, the start script is going to set that, and it's going to set the rigid body drag. And then, of course, before the car starts driving around, we're going to have to know what the first checkpoint it does want to point to is. So we'll call the calc first checkpoint function. And then we set the acceleration percent to 1, which is basically 100%. Okay. Now in the fixed update, this is a physics update function. Since the car is moving around with physics and rigid body, we're going to put our stuff in the fixed update function. And here's the turn. Since turn is using a checkpoint index, AI index, we have to make sure that that's greater than -1. And we're using a checkpoint and getting the direction that we have to turn the car to reach the checkpoint. And then we get the rotation to aim at that direction. But then for the car, we actually only rotate it towards the direction. We don't like have it point at the direction. We have it rotate toward the direction of the checkpoint at a certain speed. So it doesn't instantly point at the checkpoint, but it kind of acts like it's steering toward it gradually. And the other thing is here is to make the car move, we just add to the rigid body a force, a forward force. And how much force? It's the move speed, which, what is it over here? 1.1 times acceleration percent. So 1.1 would be the pedal to the metal. Bam, it's all the way down. And the acceleration percent is a way to say how much the pedal's pressing down. Okay. Then here we have on trigger enter. We're going to hope that when the AI car is driving around a track and it hits a checkpoint wall, that's going to register, and then it's going to go from pointing at that checkpoint to the next checkpoint. So that's what this on trigger enter is going to do. It's going to see that we did hit a checkpoint. It's comparing the tag to make sure it's a wall. All right, so if it is doing that, we're going to have to make sure that all our checkpoints have a proper tag. And right now it looks like they're untagged. So I did add a tag and I called it wall. So now they're all going to have a tag of wall. There, good thing we read through the script. Then if we hit a wall, we're going to get the number from the current wall, the wall that we hit, and then we're going to calculate what the next wall would be. That's good. On drawer gizmos, just draws a line to the checkpoint the car is aiming at. Calc first checkpoint. This is what happens when we press that button. Blue Magic here has this button, calc first checkpoint, and based on where the car is on the track, it figures out what the first checkpoint would be. And let's see what it does. It first makes sure that it initializes the checkpoint index to -1, which means we don't have a checkpoint. And then here we just make sure we have checkpoints, set. So what it does is it gets the track, it gets the child called checkpoints. So here's our track, and here's the child called checkpoints. Okay, and it just gets the transform of that. Direction forward. This is how we get our car, whichever way it's pointing, the forward direction of the way our car is pointing. We use transform direction. Okay, so it's here. It's not the world forward, as you can see. The world forward, the Z is pointing this way, but the car's forward is pointing this way. So transform direction gets us the cars forward. And what's this doing? Wall starts with the character. Oh, this is getting what the wall starts with name. It's a little tricky code that it just looks at the wall and it finds where the parenthesis is and it just gets the letters before that. So, okay, good, whatever. Then over here we got forward points ordered by distance. So now on the track, we have the car right here, and we only want the points that are in front of the car. So that would be all these points over here because the car is facing this way, and all the points on the track that are in front of it are this way. And for each of those points, we're going to see how far the car is from those points. Okay, so that's what this loop is going to do. It's just going to first collect all the points that are in front of the car on the track, and that would be those. And then it puts them in an array, which I store the index of that point. Then over here we get the distance the car is to that point, and the way we get the distance is we subtract the two vector positions, and I just get a number for it, square magnitude. Then we store the direction to that point from the car to the point. So the way we get the direction is we take the checkpoint minus the car's position, checkpoint position minus the car's position. And then we get an angle of the car to the checkpoint. Okay, so that the forward direction, the car, and the checkpoint. So this is the car's forward direction. This is the checkpoint, and the angle between those two. That's what we're getting. And then we just add it to an array. Then here, that array has all the points. Now we just order them by distance. So the closest points are in front and the furthest points are in the back. So now that we have them ordered by distance, we take the 3 closest points. So if I look at the picture, that should be bang, bang, and bong. Now for the 3 closest points, we take the one with the shortest angle, it seems. See, because here I make another array, PDS2, where I just have the 3 closest points. And now on that second array, I do an order by angle. So the smallest angle will be the first index, and that's what I set IDX to. All right, so all right, that's finding the closest checkpoint. So calc next checkpoint, right? So we're going around the track, we hit a wall, and it has to find the next checkpoint. So why didn't it just say checkpoint +1? I guess because, you know, we just are gonna try to pick a best checkpoint out of 2. So we get the first checkpoint away from the car, and the second checkpoint away from the car. And if we could see the second checkpoint from where the car is, you know, if there's not a wall in the way or, you know, part of the track is in the way, we'll try to go to the second checkpoint instead of the first one. So that's what that does. When we were picking points to here for all the forward points, how do we know if a point is in front? Is position in front is a function that I wrote here. And let's go to definition. And to know if something's in front of it, we just take this, the car's transform, and we use the inverse transform point function. So I take the car's transform, inverse transform point of whatever that point is, and the z-axis, if it's greater than 0, it's in front of the car. Then when I increment the checkpoint, I got to make sure I do the loop around when I'm at the last point, and that's what this function does. It's +1, but if you went past the last point, then it's going to loop around and go back to 0. The center of the car, this may seem like, oh, it's obviously the car's position. But no, because sometimes the center of the car, I'm making these models in Magic of Voxel, and the center of the car is actually here at the bottom somewhere. But I want the center of the rendered car, so that's where I'm using the renderer. And I just get the bounds center. When I'm looking at the checkpoints, see they all have like a number after them in the name. Extract number from string. This is just a function to extract the number from the name. And it's using regex. And that's why up here at the top we had included the regular expression. And the last function is get child by name. I'm not sure if Unity had a function to do this. I mean, I didn't look too long, I didn't find it. So I just wrote a function myself. So I had the parent object, and I go through all the children, and I look to see if there's a child with the same name as what the person passed in, and then I just pass back that child object. So that's the script. You could look on omarvision.com for the scripts, so you don't have to type them all in. Otherwise, that's how the AI control script works. Whew, let's see if it works now. Let me press play. And let's see how well this car follows around the track. Let's see, I press play. Mesh collider, rigid body, and the car is driving around. It's just crashed right past me. And it's going around the track. It's kind of skidding a lot and crashing into the walls. And then it tries to get back on track. All right, so it's kind of skidding a lot, skidding off. So what I'm going to do is I could change some of the values for the AI control. One of the values I could change is the drag, so it could stop sliding so much. So let me just try incrementing it to 1.2. Let's press play. Yeah, just crash into me again, why don't you? It's still crashing into the walls. And, oh, this is really bad. Let me increase the drag to 1.5. Go. Okay, a little better. It didn't hit the wall there. And here, hard turn, hit the wall. Hit the wall. Let's see if we make it turn faster. 120. Turn faster. So I guess there's a number of things I could do, like position the checkpoints a little bit better, like not so close to the wall. I'll play around with these values or the speed to have it not crash, but this is my first setting for, let's try 1.8. Okay. And, ooh, that's a hard turn. Good. So that's going around the track. Now let me try driving and keeping up with him. Let's see when he comes. Oh, there we go. He just went that way. I'm going the wrong way. Come on, can I catch him? Can I catch him? Let's go. Let's go. Oh, I see him up ahead. Here I come, baby. Here I come. Woohoo! Nope, I'm not coming. You're way ahead of me. All right, so we got an AI car, and the easy thing is we just duplicate that AI car. So we're getting a racing game coming along here. There we go.